1.2, finding limits graphically. Last time we talked about one-sided limits. Now we're going to talk about a general limit. And here's the definition of it. For a general limit to exist, this is that the limit as x approaches some number from the left of a function must equal the limit as x approaches that same number from the right of the same function. So we have to be coming to the same y value for the general limit to exist. So we're going to be using the same graph for questions 1 through 6. It says evaluate both sides of the limit, the general limit, and the function value at the given x value. So number 1 is at x equals -2, which is right here. So you're looking here. Okay, so we want to come from the left, and the biggest part is getting used to writing this weird notation. We're going to say the limit as x approaches -2 from the left of f of x equals, so if I'm coming from the left, I would go this way, and I'm at a y value of -6. Okay, then I'm going to do the same thing for x as it goes to -2 from the right. And then that would be down here, so that would be at -6 as well. So because these two values match, coming from the left and the right, then I can say that the general limit as x approaches just -2 of the function is -6. And then the last thing they want us to do is give the function value. So what y value do we have when x is -2? That would be -6. So I'm going to put f of -2 equals -6. I have to write a little smaller. Now we're going to do it when we're approaching -6. So I'm going to set up my limits. Limit as x approaches -6 from the left. Limit as x approaches -6 from the right. And the limit as x approaches -6 just in general. F of x. All right, -6 is right here. I see that there is a break in the graph where the piece is going to different y values, so that's going to tell me that the general limit is not going to exist. When I'm coming to -6 from the left, that would be this piece, I am approaching a y value of -4. When I'm approaching -6 from the right, that would mean I'm following this piece, I'm coming to a y value of 0. Because these numbers do not equal, this is a does not exist. DNE is what you put. Okay, and then I need to figure out what is f at -6. What is the y value at -6? That is where the close point exists, and that is at a y value of 0. I think you're getting it. Go ahead and try number 3. You should have the left-handed limit equals 3, the right-handed limit equals 3, so the general limit equals 3, but f of 3 is not 3 because there was an open circle. The close point is really at f of 2, or at 2, sorry, f of 3 equals 2. So again, just because there's a close point somewhere else doesn't affect the limit. It's the lined part of the function. What is it approaching? All right, so now I want you to pause and try 4, 5, and 6 on your own and then check them with me. The answer to number 4 is that the left-hand limit approaches 0, the right-handed limit approaches 4. They're different values, so therefore the general limit does not exist. The value at 1 is 4 because that's where the closed circle was at. Number 5, the limit as the function goes to 5 from the left is 3, from the right is 3, so the general limit's 3, but there's an open circle at 5, so it's undefined. You know, number 6, let's just say that that's at 0. I know it's a little bit less than that. Could be -1/2, actually, is what I probably should put, but we're just approximating and just understanding limits. So everything should be the same, the right-handed, the left-handed, the general, and then there is a function value there because there's no holes. Okay, so -1/2, -1/3, whatever you think that is. Yeah, I definitely don't think it's 0 now that I'm looking at it, sorry. All right, and then the last thing can happen is what if there's an asymptote? So we got a new graph here. Asymptotes, remember, are some kind of vertical or horizontal, or it could be a slant which is a diagonal line, where a function is never going to touch. So at x equals 3, if I want to find the limit as x approaches 3 from the left of f of x, I would come from this way and follow it. So I'm going to keep going down and down and down and down and down and down forever. So I can say that this approaches negative infinity, or I think Delta Math will take a does not exist on that, because infinity is not an actual value. It's not a numerical value we can label, right? So it'll take either answer. For one-sided limits, I kind of like the infinities, honestly, but either one. All right, let's do the right-handed limit. So limit as x approaches 3 from the right of f of x. So I'd be following this piece. It's going to go up and up and up and up and up forever. So we'd say infinity, or again, I think it would take an answer D and E. But the thing I do need you to know is that the general limit cannot be an infinity. Okay, so general limit on this, I don't know if you want to make a note of that, cannot ever be an infinity. Only rights and lefts can be. The general limit has to be a number. So on this one, if we got one end going down forever and one end going up, there's no number that will approach from the left and the right that's the same. So this is definitely D and E. It's the only answer they'll take. Even if we had two where they were both like coming up, you know, we were both ends going from right and left up to infinity, that wouldn't be infinity for the general limit. You could put that for the one-sided limits, but you would still have to put D and E. Okay, and then obviously f of 3 is undefined. I'm not sure if they'll take does not exist on those or not. You might want to try it and let me know.